rational expressions.
Okay.
Alright, the first one is,
Let me get it, my writing tool here. All right.
So it's 15x over 25x squared.
Start with the number, and you just have to simplify this?
Yep.
Start with the numbers, and then go to your first variable, and then go to your second variable. So what's 15 over 25 equal?
What do you mean?
Simplify 15 over 25.
Oh, okay, so that would be 3 over 5.
So 3 goes in the numerator, 5 goes in the denominator. Now simplify the first variable you come to. X over x squared. What is that?
That would just be x, right?
Where? In the numerator or the denominator?
Denominator.
Yeah. That's your answer.
Mm-hmm.
And they're all that simple, it doesn't matter. I could have 15x, y, z, all over 25x squared, no y, z cubed. And you do them all exactly the same way. You handle the number, then you handle the next variable, then you handle the next variable, then you handle the next variable until you're done.
Mm-hmm.
And it's basically as simple as that. It doesn't really matter how many variables there are. It's the same process, you're just repeating it. So what next?
Okay. Alright, next one. 12x squared over 3x plus 6.
Like that?
Yeah.
What can I do to top and bottom?
Simplify.
In other words, I cannot make this 12 over 3 a 4 because the 3x has a 6 added to it.
Right.
But what number can I divide top and bottom by?
X?
No, there's no x on that 6. So I can't. 3, exactly. So the top becomes 4x squared. What's the bottom become?
Over x plus 2.
That's your answer. There's no way to simplify that.
Cool. Alright.
And let me just make one statement. If you have a single entity in your denominator, then you can split it up into 2 fractions, like that.
Mm-hmm.
But if you have 2 things in your denominator, you cannot split that up. That is not equal to a over b plus a over c. You can only split it into 2 fractions if you have a single thing in your denominator. In this answer that we have, I've got x plus 2. That's not a single thing. So I can't really split it up into 2 fractions. Not that that would always does any good, but I can't do it. So this is as much as I can simplify it. It looks like you should be able to do something with that x squared and x, but you can't. Because it's not really x, it's x plus 2.
Okay.
What else?
4x plus 2 over 2x plus 1.
What can I do to the top? Think factoring. Always think factoring.
You can
Factor out of the top.
Oh, a 2.
Okay, what are you left with?
2 parentheses 2x plus 1.
Now what can I do?
You can cancel out the 2x's and the plus 1.
Got to be able to do both of them. You can't just do the 2x.
Yeah.
Have to be the same thing. 2x plus 1 is the same as 2x plus 1, so that together is equal to 1. So this becomes 2.
Yep. Alright. Next one is 2x minus 12 over x squared minus 7x plus 6.
Again, whenever you have these rational quotients, the answer usually lies in factoring. So factor the numerator and then factor the denominator and see if you get anything in common which can cancel out. Factor the numerator.
Okay, so that'll be x minus 6
What's the
x.
greatest common factor? Always, when you're factoring something, always start with greatest common factor to see whether you can do that.
What do you mean?
Well, is there a greatest common factor between 2x minus 12?
Oh, you're talking about the top.
That's, yeah.
I thought we were doing the bottom.
You
Okay,
want to factor both. In other words, you want to start with your numerator and then see if you can factor your denominator. Can I factor the numerator?
Yeah.
To what?
2 parentheses x minus 6.
Now, let's factor the denominator, and if we're lucky, we'll get an x minus 6.
Yeah, it'd be x minus 6, x minus 1.
That cancels with that because there's nothing but multiplication going on. So your final answer is this.
Alright, cool.
And again, I cannot split that up into 2 over x minus 2 over 1. Because I got 2 terms in the denominator. And all of these problems are probably, once you factor the numerator, it kind of gives you a clue. You're looking for an x minus 6 in the denominator. If you don't get an x minus 6 in the denominator, then you can't really do anything else. And they've designed these problems so that you can simplify them.
Right.
Okay, keep going.
Alright, the next one is x squared minus x minus 6 over x squared plus 5x plus 6.
Factor the numerator.
X would be x minus 6, x plus 5.
No, let's do it step by step. I want to review factoring. How do you factor that numerator? What's the first step?
Factors of 6.
No, that's not the first step. That's the third step.
Oh, well, x is...
First step, split up the x squared.
Yeah.
Second step is determine both signs.
Okay, so they'd be negative.
Nope, you can't produce a negative 6 if they're both negative. That would be a positive.
Negative and positive.
There you go. One has to be positive, one has to be negative. I only have to write it once because it's x and x. So plus minus is going to be the same as minus plus. What's the third rule? Factors of do what?
Factors of 6 subtract to be 1.
To be what?
1.
Perfect. What factors of 6 subtract to 1?
6 and 2 and 3.
There you go. Where does the 3 go? Where does the 2 go? The larger factor goes with the sign of the middle term.
So 3 goes with subtraction, 2 goes with the addition.
Now notice the first time you did this, you said 6 and 5. Well,
Yeah.
you have to multiply to the number 6. So you could have been right if it was 6 and 1. But the only other options are 2 and 3. They always have to multiply to that number. Because notice what we're doing. We're going to FOIL that, right?
Uh-huh.
And the last step of FOIL is multiplying the plus 2 times the minus 3 to get that constant, minus 6. Factor the bottom by the same method.
So split up the x's, and then it would just be
What are both signs? I really want to see you do this
positive.
step by step by step, because you'll never get it wrong if you do. The people that have problems are the ones that try to skip step 2. Step 2 is the most important step.
And then it would be factors of 6 that had to be 5, so it would be 3 and 2.
Now what can I do?
Cross out the x plus 2's, and then you're left.
That cannot be simplified. That's your final answer. Now, let me just tell you one thing in case we don't see this problem. What's that equal to? -1. It's the only time that you can cancel them out when they're not identical is if you happen to have a minus b divided by b minus a. That is always -1. Nothing else, everything else has to be identical to be able to cancel it out. But in this case, I can do this and replace it with a -1. It may come up, it may not. Depends on how tough your teacher is. What else you got?
So now we're doing multiplication.
Okay.
3x over x minus 2 times 3x minus 6 over x squared.
Yeah. Okay. What's the very first thing you can do?
Would you cancel out the 3x?
No, can't do it. This 3x has a -6 with it.
Oh.
However, I can cancel out that with that. I can simplify it. What is x divided by x squared equal to?
Say that again?
Okay, what I'm going to do is cancel that out with that exponent, making it a 1. So now I have the following. 3 times 3x minus 6 all over x minus 2 times x. See how I could do that? Okay. Now I'm not done. Is there a greatest common factor in that? Think numbers, then think variables.
That would be 3.
Okay, what's left over?
3 parentheses 1 minus 2.
X minus 2.
x minus 2.
Notice
So.
the 3 times x minus 2 is 3x minus 6.
Mm-hmm.
And I have an x minus 2 in the bottom, which is wonderful. Now notice, the only reason I can cancel these out is because it's multiplication. I'm multiplying 3 times x minus 2, and in the denominator I'm multiplying x minus 2 times x. So because there's nothing but multiplication, I can cancel that with that.
Right.
Gives you 9 over x.
Right.
Okay.
Next one is 5x cubed over x squared times 3x to the 4th over 6x.
Like that?
Yes.
Okay. There's various things you can do to begin this. What first step would you take?
I would cancel out the x's.
Which ones? There's a bunch of them in here.
I would do the x squared and x to the 4th. Makes it x squared.
No, it actually makes it x to the 6th. When you're
X
multiplying, you add the exponents.
Oh, yeah.
When you're
Well, no, aren't you
dividing, you
canceling out
subtract
it,
the
though?
exponents. What's that?
Aren't you canceling them out, though?
No. This is a little bit complicated because I have a fraction with the denominator being a fraction. So the simplest way to do this is to let's get rid of this x with this exponent. So this whole thing becomes what? What's the denominator become?
Wait, I'm just confused.
Okay.
So, why wouldn't the x squared cancel on the 3x to the 4th to 3x squared?
Because they're being multiplied. You add the exponents. So that would be 3x to the 6th.
But you're not multiplying them if you're canceling them, right?
No, you're either multiplying or dividing. You got to know which. That is multiplication. Oops, sorry. That is multiplication.
Right. You're multiplying, but when you cancel them, don't you just cancel them out, or no?
No? Here, let me show you. The numerator, we're not doing anything with it yet. The denominator, I'm going to multiply x squared times 3x to the 4th, which gives me 3x to the 6th. I still have that 6x under there.
Okay.
Now simplify that. Now we're dividing. What does that become?
Alright, that becomes 2 over, 1 over 2x. Alright, so it would be x to the 6th over
Actually,
2.
x to the 5th. Because there's a little 1 right there. It's not written. And I'm dividing, so I'm subtracting exponents. So 1/2 x to the 5th is the same as that. Now I got this. 5x to the 3rd in the numerator divided by 1/2 x to the 5th. First of all, what's 5 divided by 1/2? Do the numbers.
5 divided by 1/2 is just 2.5, right?
No. How do you divide by fractions? Use your methods. Use your methods that they've taught you. Always. When you divide by a fraction, what do you do?
Copy dot flop.
Okay, what do you do when you get 5 divided by 1/2? Flip the denominator and multiply.
That would be 10 over 1.
Okay, just 10. That gets rid of
Oh.
that, gets rid of that.
Uh-huh.
Now we still have x to the third divided by x to the fifth. We've
Uh-huh.
simplified our number, but we got to simplify our variable.
Mm-hmm.
What's this become?
That becomes x to
Just subtract the exponents.
so it'd be 10 over x to x squared.
Yeah. Or I could choose to write it like this, because my first process is to subtract the exponents. And I know what a negative exponent means. It means I'm going to use a positive exponent on the other side of the fraction bar. So that is the answer.
Okay.
And there are numerous ways you could begin this problem. You don't have to do it the way we did it. There's lots of different methods of finding that answer and lots of different ways to begin. You just have to begin somewhere and make sure you don't make a mistake to eventually get to 10 over x squared. And most likely your teacher has said do not give negative exponents in the answer. So 10 times x to the minus 2 would not be acceptable. You might lose points if the teacher has said use only positive exponents. So you really do need to write it as 10 over x squared. If they have, if they haven't said that, then this is a perfectly fine answer. It's the same answer, it's just got a negative exponent. What else, Blake?
All right. So it'd be 5x, or we did that one just now. All right. So now we're okay. So x squared plus 5x plus 6 over x minus 3, and then times x squared minus 2x minus 3 over...
Oh, really? Like this? Okay, go ahead.
Oh, no. So it's x minus 3, and then it's a new fraction. So just times against a new fraction. So the x squared minus 2x minus 3 is a numerator on another fraction.
I'm confused.
Okay, so remove the x squared minus 2x minus 3. And then it's a new fraction.
Okay.
Or times into a new fraction.
Okay.
That is x squared minus 2x minus 3. No, it's like a whole new, like, fraction, like, to the right of the multiplication sign.
Okay, there is no multiplication sign. The parentheses are the multiplication sign.
Well, yeah.
So I still don't know what goes over here next to it.
Well, here, alright, so here it's using a dot for a multiplication sign.
Okay, there's the dot.
Right, but it's like a whole new, like...
You mean the dot's up there?
Yeah.
Ah, okay.
And then it's
Not
x
part of this
squared.
fraction. Okay.
Right. And then it's x squared minus 2x minus 3 over x squared plus 3x plus 2. Yeah, like that. Okay.
What kind of problem is this?
Uh,
All of these problems are the same problem.
Quadratic?
They're all factoring problems.
Oh, factoring.
The way you solve all of these is just to factor everything you can factor. And then you'll see that a bunch of stuff cancels. Okay, so let's start with the top left. Factor that.
Okay.
Here, let me write in blue so it's not confusing.
Alright, so it'd
Top
be
left.
split up the x's, and then both signs are positive, and then it would be 3 and 2.
Okay. I can't factor that, so I'll just leave that the same. Now
Alright,
factor the top right.
so it would both be x, or split up the x's, then it would be a negative and a positive, and then it would be, it would be negative, or negative 3, positive 1.
Good. And factor the bottom. It's a quadratic also.
Okay, so split up the x's, both positive signs, and then it would be a 2 and a 1.
Now you have everything factored. Go to town on canceling. Tell me what I can cancel.
Okay, so you can cancel an x plus 2.
And be
X,
sure you understand that when I say cancel, what I'm really doing is replacing that with a 1. In other words, x plus 2 over x plus 2 is 1. I don't write it, but it's presumed. What else can I cancel?
X minus 3, and then the x plus 1's. No?
Okay, well, it's x minus 3 and x minus 3.
Yeah, and then the x plus 1's.
So what am I left with?
X plus 3.
That's it. There's your answer. And all of these problems are exactly like this. Whenever you have rational functions multiplied by rational functions, they're factoring problems. That's all they are. And then you just cancel where you can cancel, and whatever you're left with, you're left with. Okay?
Okay. Alright, the next one is, so x squared, we're into division now.
Oh, what?
We're doing division now.
Okay.
Alright, so it'd be x squared plus 3x plus 2 over x squared.
Whoa. Okay. Give me the entire numerator.
Okay, x squared plus 3x plus 2
Over
x squared minus 4x plus 3. And then a division symbol in the middle. And then a new fraction, x plus 2. And then over x minus 3. Yeah, okay.
We don't like doing division, ever. So how do I handle doing division?
When you just do copy and then dot and then flop.
Yeah, so this is the same as, let's first of all rewrite the whole problem as a multiplication problem, not a division problem. Turn that into a multiplication sign and flip what was being divided. Now, we got this. What do we still have to do?
You gotta factor.
Okay, factor the top left.
So split up the x's, and then it would be both positive signs, and then be 2 and 1. And then under that, it would be split up the x's, be 1 negative, 1 positive sign, and then it would be negative.
They both be positive, right?
They'd both be.
Both be
No,
negative.
one would be positive, one would be negative.
No,
Right?
you cannot produce a plus 3 if they're opposite.
Oh yeah. Okay, so then it would be.
They're either both plus or they're both minus. And look to the middle term. If the middle term is minus, then they're both minus.
Okay. So negative 3, negative 1. And then.
And I'm multiplying that by, I can't factor these anymore. So, treat
you would
cancel.
x minus 3, and after you cancel those, x plus 2. And then you're left with x plus 1 over x minus 1.
There you go. That's the way you do all of these.
Mm-hmm.
The only difficulty is when you find a situation like this. That's the one situation where you can simplify where they're not exactly the same.
Mm-hmm.
That's minus 1. Now, so far,
Okay.
we haven't had any like that. You may not get any like that. But I want to keep reminding you of it, because that's going to be your hardest problem, is when they give you something like that.
Okay. Okay. Next one. Alright. It would be 5x squared plus 10x minus 15 over x squared minus 6x plus 5. And then the division symbol. And then new fraction 2x squared plus 7x plus 3. And then under that, 4x squared minus 8x minus 5.
Okay, so every one of these is a quadratic.
Mm-hmm.
That means they can all be factored. They're not going to give you a problem that can't be factored, because that's the whole point of this exercise, is factoring. Okay, so let's start with the top left.
Okay.
Take a greatest common factor out of that. And that's always what you should do if you can do it.
So
In other
would be
words,
5.
that's going to be a difficult quadratic to factor. It just is. But if you get rid of the 5, it's going to be an easy quadratic to factor. Right? In other words, easy quadratics are ones where the x squared coefficient is 1. So how about we start by doing this? Just factor the bottom real quickly for me. There's no greatest common factor in the bottom, so I can factor it.
So it'd be both negative signs, and it would be negative 3.
I like your factoring skills, Blake. You know how to factor. I'm serious. You don't get a lot of students that learn my method, because my method is not what they teach you in school. So whenever I find somebody that has actually learned my method, I'm proud of you.
Thank you.
So what numbers go down here on the lower left? What are factors of 5? You don't have a lot of choice.
Oh, so what was the question again?
What are factors of 5?
5 and 1. Or 3 and 2, sorry.
No. 3 times 2 does not equal 5.
What am I doing? Oh my god.
That's okay. That's a common mistake. 5 and 1 is correct. And that produces this quadratic, x squared minus 6x plus 5. Okay? Now, before we do the next part, let's change it to a multiplication problem. Factor the top, which I mean factor this one right there, because that's the top. Once I change it to a multiplication problem, this denominator goes in the numerator. So factor that.
Alright, so 2x and then x, right?
Hold on. Does 2x times x equal 4x squared?
I thought we were doing the top.
We are, but the top is this.
What?
I flipped.
Oh, because we flipped. We flipped, yeah.
Exactly. I didn't have enough space to rewrite it 100 times, so I tried to do 2 steps in one. So we're
So
factoring
you're
what I have in the rectangle
okay. So it would be 2x and 2x.
here. Okay. Signs?
Um, they would so it'd be both be or no, they'd both be positive, right?
How can you produce a -5?
Or one negative, one positive.
Always. Always look to that sign of the constant. That tells you what the two signs have to be. And
Uh-huh.
in this case, because I have a 2 in front of the x on both sides, I only have to consider plus minus. It's going to be the same as minus plus. So I don't have to write both.
Mm-hmm.
I merely have to find factors of 5. What are they again?
Um, it would be 5 and
Only
1.
2 factors of 5.
5 and 1.
Okay? Do we know whether it's 5 and 1 or 1 and 5? Let's just try 5 and 1. What's that produce for a middle term?
That produces a negative or negative. Oh, middle term.
Uh-huh.
That's negative 8x. So yeah, that
Not
works.
negative.
Or oh yeah, positive.
Positive
So just
8x, which means I got to do what?
switch them.
Yeah, exactly. In other words, it's not 5 over here. It's 5 on the right and 1 on the left. Now what's my middle term? You always get your middle term by doing the inside and the outside, or what I call my double smiley face.
Mm-hmm.
That gives you minus 8x. Because this gives you 2x on the inside, minus 10x on the outside. Add them together, you get minus 8x. You with me?
Mm-hmm.
So that thing's fully factored. Now I got to factor this thing.
Right.
So factor that.
So it'd be 2x and x, and then it would be um 3 and 1. The signs would be
Times,
both positive,
times, positive, positive.
and then
That's a
there's
critical
only
step in factoring.
right, and then there's only 3 and 1. So
Is it 1 and 3 or 3 and 1? What's going to produce 7x?
it would be 1 and 3.
Yeah. Okay. The only thing I haven't factored is this top left numerator.
Mm-hmm.
Let's factor that.
Um. So that would be x, split up the x's, and then it would be positive and negative, and then it would be 3 and 1, or -3, +1.
No, you had it right the first time.
Or no, yeah, I had it right. I had it right.
You
Yeah.
go with the sign of the middle term is the higher factor. 3 is the higher factor than 1. So the 3 goes with the sign of the middle term, which is a plus. Now, let's go to town canceling.
Wait, so say that again.
Let's finish. So far, as all we've done
Oh.
is factored everything. Here's my numerator, 5 times x plus 3 times x minus 1. Here's my denominator on the left, and there's my numerator and denominator on the right. So the next step is
Mhm.
to cancel wherever we can cancel.
Okay.
Tell me where.
So cancel x plus 3.
Whoops. With that one, okay.
And then cancel the 2x plus 1s.
Okay.
And then x minus 1.
Okay.
And then that's
What
it.
am I left with? Yeah, I got a 5. You can't forget that 5.
Or can't you cancel the x and the x or no? Or
No,
no, because it has a
no,
minus
never.
5. Right.
Not if there's a number being added to it. You can't. Okay. So what I'm left with is 5 in the numerator, and I still have that numerator. So 5 times 2x minus 5. And what am I left with in the bottom? That's been canceled, that's been canceled, that's been canceled. That's the answer.
So, that's the answer. We just leave it like
Cannot do
that.
anything else. No. Notice I can't do anything with the 2x minus 5 over x minus 5. They're not the same thing. They got to be the same thing. Or that a minus b over b minus a. That's the only time you can cancel something that is not exactly the same thing. So you could put the 5 back in, but I wouldn't. I always leave answers factored. Because you never know what you have to do with that answer. Maybe they want you to take that answer and multiply it by some other fraction. In which case you're far better off if it's already factored. That's the final answer and cannot be simplified.
Okay.
Okay? These are all pretty standard. In other words, they're all factoring problems is what they are. Every one of them. Now, if they really want to give you a tough one, they'll give you one that produces like an x minus 3 on the top and a 3 minus x on the bottom. That's the one time you can cancel without them being identical. So far, you haven't had any of those, so we won't worry about them at the moment. We only have about 5 minutes left, so maybe you want to jump down to the bottom where they're harder.
That's all I have on the worksheet
Oh,
right
that's all
now.
you have? Okay.
Yeah.
Well, I'll make one up. No, then I'll let you go. I'll make it a little harder. Can you do there? Can you do anything with x plus 5 over x minus 5?
No, you can't.
They're not the same. You cannot do anything with them. Can you do anything with x minus 3 over 3 minus x?
What?
Can you do anything with that over this?
No.
Actually, you can. That's the one time where you can replace that with a minus 1. In other words, I can cross them out, but I got to leave a minus 1. Because that's what that is. X minus 3 over 3 minus x is minus 1. So now that gives you a minus x plus 5 all over x minus 5. Or, if you prefer, x plus 5 over 5 minus x. That's the answer if you don't want a negative sign anywhere. In other words, I took this negative sign and I switched those two. Still can't simplify it. There's nothing I can do with x plus 5 over 5 minus x. You can do something with a minus b over b minus a. That is always equal to minus 1, no matter what a and b are. But that's it. In other words, it has to be subtraction and they have to be in the opposite order. In other words, you can't do anything with that. X plus 5 over x minus 5. They're not both subtraction.
Mm-hmm.
Okay? All right. Blake, I will let you go. And when did you say our next? Oh, yeah. So we have a half hour tomorrow at 6:30.
Mm-hmm. Yep.
Talk to you then.
Yep, you too. Thank you.
Bye-bye.